Hey, Tim Unkert here, and in this video we're going to create a worksheet in English and Spanish of inverse functions. We're going to use Markdown and Latex to do that, and I'm going to program the worksheet in Python. If that interests you or videos like that, please like, subscribe, and hit the bell for notifications. It really helps the channel grow. Okay, let's get started. So I'm going to create a main.py. I'm going to create a lists.py, and I'm going to create a functions.py, all in the same folder. We'll start off with our main. I'm going to import OS, import sys, and import random. Okay, the first two are going to help me to basically compile with the classes from the other files, and then the third one is going to allow me to have some random choices. Okay, so I'm also going to type sys.path.append and then just a dot. So that's going to also help me to import the classes. Okay, and then for the classes, I'm going to say from lists import list, and then from functions import function. Okay. All right. Okay, so after that, I'm going to say that rand, we're going to make this variable rand, that equals the list class, okay? And we're going to create some files, and then we'll move to some of the function files. So we're going to say inverse function file. We're going to open a file, and that's going to be a markdown file. So it's going to be inverse function.markdown, and we're going to append to that file. We're also going to have inverse function Spanish file for our Spanish version, and we're going to open that and call that one inverse Spanish function.markdown. We'll append to that file. And we're also going to create one, we're going to call it inverse function solution file. And that's going to be a LaTeX file. So we're going to call that inverse-function-sol for solution.text for the LaTeX file, and we're going to append to that. Okay. Now let's go to our functions. All right, so we're going to create a class, and we're going to call that class function, and we're going to instantiate the class. We'll pass in the self, we'll pass in coef1 and constant1. These are going to be linear equations that we're going to basically find the inverse of. So I'm going to say self.coef1 equals coef1. Self.constant1 equals constant1. Okay, and let me take a look at my notes here because I'm working off this, off some notes. So we're going to create another method. We'll call that the f of x string, and I'm going to pass in just self there. That'll allow me to use this coefficient 1 and constant 1. And I'm going to create a variable f_func string. That's going to be the string. We'll make it an f string. We're going to pass in self.coef1 times x plus then just constant 1. Okay, we'll close out that string, and then at the end of this method, we'll just return the string. Okay, we also have to have a method for the solution. I'm going to call that solution string. This one's going to be a bit more complicated because we're going to be writing to the LaTeX file. So we're going to start off with the solution variable equal to an R string. That'll allow me to put in the slash and the brackets without them actually, that's just going to print the slash and the brackets right to the file. So I'm going to print the LaTeX code right there. And then we're going to say solution, we're going to append with plus equals, and then just do an plus equals, and then just do an escape character to move down to the next line, then solution plus equals. Now, I did struggle with getting this correct. Looking at the documentation, it was not very great online, so I kind of had to play with it for quite a while to get it to work. So hopefully it's helpful. Anyway, so we're going to do another R string, and then thank you for that. And then we're going to do F and raise it to the, we're going to have it like -1 superscript, like a inverse function notation. Okay. And then I'm going to write solution plus equals, oh, sorry, I should have had an R string here. And then we'll go down here, another R string, okay, and do a \frac for the fraction. Then we'll just open it here, and now we have to pass in stuff with an F string. So I'm going to say solution plus equals, then we're going to have an F string, all right? And I'm going to have, for the top, the numerator, I'm going to have self minus, or x minus self.constant1, okay? We'll talk about why that is in a moment. Then we're going to have solution plus equals an R string. I'll have a closing curly braces and an open curly braces. That's going to move me down to now the denominator. So I'm going to say solution plus equals. The denominator is going to be the coefficient. So self.coef1. And then we're going to close this off. Solution plus equals. Do an R string and close that out. And then solution plus equals. Then we'll do a /n there. And then we're going to have to finish that with an R string. So we have solution plus equals. So we brought it down to the next line, do an R string, that's a /n, brings it down. And then we do a slash and a closing bracket. And then we're going to return the solution. So that's our string, okay, that we got there. All right, so we're done with that file. We also want to create a lists file. That's just going to give me a random list. So I'm going to say class is list. Remember, because we had rand equals a list class. And we're going to create a method called random list. And within that, we're going to say create a variable called a random number list. That's going to be an empty one. We're just going to populate it. We're going to say for x in range 1 to 51. That's going to give me numbers 1 to 50. It goes one less than the top number. We're going to take the random number list and append x. Okay, and then we are going to return the random number list. Okay, we're going to hit Control S to save that there. All right, so let's go back to our main file. Let me take a look at the notes here. Okay, so now there's some other things we need to write at the top of the LaTeX file. So I'm going to focus on the solution file here. So I'm going to say inverse function solution file dot write, and then I'm just going to duplicate this line. Okay, because we're going to write a bunch of stuff. Okay, all right, so I'm going to start with an R string, and then we have to have the document class, and that's going to be article. Okay, and we'll just close that. And then we're also going to just bring it down to the next line. So I'm going to have a /n/n for formatting. And then we're also going to do another R string, and we've got to use a package to make this work. So we're going to say use package, and then AMS math. Okay. And then we'll have to do another /n/n for formatting. After that, we're going to have to begin the document. So we're going to do an R string begin, spell that if I can spell it correctly, and then document. No, I don't want to just want to delete one of those, and then, another /n/n just for formatting. Okay, so that's going to start our LaTeX document. All right. Now we're going to start the problems. We're going to say for problem in range 1 to 101. What we're going to do is we're going to say that coefficient 1 equals random.choice. Remember, we imported the random module. And then we're going to take that variable rand, which is equal to the list. That's an object that we set to the list class, right? So we're going to take that and pass the random list method. Okay. I'm just going to duplicate this line and change this here to constant 1. Okay. All right. So we're also going to create another object, and that's going to be the new problem. And that's going to equal to the function class passing in coefficient 1 and constant 1. After that, we'll start writing to our files, and we want to write the problem number to start. So we're going to say inverse function file.write, and we're going to do an f string, pass in the problem, and then pass in the actual variable problem, which is going to be 1 up to 100. So each time we iterate through the loop, it's going to increment up by 1. So we're going to say problem 1, then problem 2, then problem 3, so on and so forth. Okay, I'm just going to duplicate this line twice, and then we'll do the solution file and then also the Spanish file. And for the Spanish file, I'll put problema. Okay. All right, so next up, what we're going to do is actually for each of these, hold on, I forgot to do one thing. We also want to have a /n/n at the end of these just for formatting. Okay. All right. Okay, so now what I want to do is write to my inverse function file. And I'm going to say write, not warning, write. And then we're going to write what is the inverse function of f of x if, have a space here, move it to the next line. We'll again go with the inverse function file. Why is it doing a warning? It's annoying. Right, and then we're going to say, we're going to write in an f string, and we'll say f of x equals the new problem method, and we're going to use the new problem class object with the f of x string method in there. Okay, and put a question mark at the end, and then a /n/n. We're also going to write to the Spanish file. So we're going to say inverse function Spanish file dot write, and then we're going to write. So what I want to do is go up to here and search English to Spanish, and I'm going to type what is the inverse function of f of x. If, okay, we're going to take this, copy this right here. So copy that with the upside down question mark. So, and then qualis, and then we have C. Okay, we're going to move down, keep this line from getting too long. Take the inverse function Spanish file and write, and then do a space. Okay, and then we'll do. We also want to do an f string, space, and then f of x. It's going to equal the new problem with the f of x string. And we have to have a question mark at the end, and then a /n/n. Okay, moving on. All right, so now I want to write to my solutions file. So I'm going to take my inverse function solution file, and we're going to write, and what we're going to write is an f string, And we're going to pass in the new problem with the solution string. And then at the end of this, we'll do a /n/n, close our quote there. And then also for the inverse function file, we're going to write, because this is Markdown, we can do a little line with the 3 dashes there, and then a /n/n just to bring it down. I'm going to duplicate the line and do the same thing for the Spanish file. And okay, so that's the end of our for loop. Once we move out of the for loop, we've got to do something at the end of the LaTeX file. So I'm going to take this inverse function solution file, and we're going to write, and then we're going to write an R string, and we're going to write /end, and then in the curly braces write document, and that's going to end our LaTeX document. After that, we're going to close all the files. So I'm going to take my inverse function file and close it, and we're going to do that for each of the files. So I want to do that for the Spanish file, and I want to do that for the solution file. All right, I'm going to save this. Now I'm going to pull up a terminal, and let's run it. Okay, so let's actually look at the files here. Watch on the side. We'll pull up the terminal, and I'm going to type Python 3 main.py, and we've got an error. Okay, const1 is not defined, and the reason why, let's exit out of this. Actually, before we do that, because it did create these extra files, so let's just remove them. So we're going to remove the star.markdown and the star.tech. Okay, so we're back to our main files. Exit out of there. Made a little error here. I forgot to pass self.constant1, so that will throw an error if you do that. Let's pull back up the terminal and rerun, and there we go. Okay, so we've got all these files created. Let's go to the LaTeX file. Now this may show some errors because I do have a plugin. It's going to give me a few errors here, blah, 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 but it'll still work. Okay, so I'm going to go and take this LaTeX file, and I'm going to output, instead of .tex, .pdf. And I'm going to use PDF latex. So what I have installed is Pandoc and TextLive LaTeX Extra. Okay, and we went ahead and installed the PDF, and now let's take a look. Okay, and we're going to go to our Linux files, to the YouTube one, to the inverse, go to this PDF. You'll see that the solutions are formatted very nicely. Okay, what I did, let me step back a minute. So I forgot to mention one thing when I was going through here. I got going a little fast here. Sorry about that. Let me just actually create example.text. Why this is. Okay, so we wrote functions like this. So f of x equals basically some coefficient, say times x plus some constant. That's our form, right? So now to find the inverse of that, let's talk about that. So there's 4 steps. Step one is replace f of x with y. So let's go ahead and do that. So we're going to then rewrite it as y equals, then we'll have coef 1 times x plus then constant 1. Okay. Step 2 is to switch x and y. All right. So if we do that, we get x equals coef 1 times y plus then constant 1. Step 3, we solve for y. Okay, so to do that, I would have to subtract constant 1. So I would get x minus constant 1. So let's do that. X minus, and you'll see why I'm putting these in parentheses in a moment. And then y is multiplied by coefficient 1, so we'd have to divide both sides by coefficient 1. So we're going to get our denominator of coefficient 1. And then the final step, is just to replace y with the inverse function notation, which is f with that superscript of -1 of x. Okay. So if we look back at our PDF here, we'll see that we have f -1 of x equals x minus the constant divided by the coefficient. Okay. If we take a look, let me take a look here, go back here to our Markdown file. Okay. We got a little error here. Okay. Because we forgot an f string. All right. Well, I'm going to have to fix that up. Okay. Let's go back here. Where did I forget my f string? In the functions file, probably. Oh no, I know what I did. All right, so we didn't forget the f string, but we've got to put it in the curly braces. So we got to do that. Okay. That should be okay. But for all intents and purposes, let's take a look at the Spanish one, because they're going to be the same, just different, obviously Spanish versus English, but we have 25 as our coefficient and 26 is our constant. So if you remember, we take a look back here, 26, x minus our constant divided by our coefficient. Okay, so that's the basic format for these problems. Okay, so now I did make that error. Okay, so how am I going to fix it up? It's a lot easier than you think. Okay, so I've got all these files created, but now they're not going to sync because I have to recreate them. So what am I going to do? I'm just going to remove them all, and I'm going to rm-rf star.markdown, star.tech, star.aux, star.log, and do we have a sync file? No, I think that's it. Okay, we're going to remove those. Oh, and we got to get the star.pdf. Boom. And we got our example.txt, but that was just showing the example, so that's no big deal. Okay, so, and then the other thing is I don't want to save these. I don't need to have that open. I really don't need to have anything open, but now that I've fixed this, okay, let's go Control-Shift-T. Let's rerun the Python. Okay, we created the files. Let's take a look at our Markdown file now. Okay, so now if it's formatted correctly, what is the inverse function of f of x if f of x equals 4x plus 27? Okay, our Spanish function still formatted good, our Spanish file, and then our LaTeX file. Okay, so we've got our LaTeX file. We can just, again, Control-Shift-T, bring up a terminal. I got a few errors with this plugin. Don't worry about that, but just do PDF LaTeX and then inverse solution function, the output, inverse function dash solution dot tech, and the output, we're going to get rid of the dot tech and do the PDF. Hit enter, and it's going to give me some information. It creates the PDF. I can open the PDF. The PDF will be formatted correctly. So we're good to go there. Let's clear this out. And now we want to also create the PDF for the Markdown file and the Spanish one. So I'm going to now say pandoc inverse function dot markdown, and then we'll output inverse function dot PDF. Okay, we'll run that. And we see that it ran and it created the PDF file. So now if we go here and open the file, we'll see we have the problems written. I may want to change this and put a name at the top, something like that, but basically all the problems are written and we're good to go. Okay, we can do the same thing for the Spanish one. And then you got worksheets with English, Spanish for inverse functions, along with nicely formatted solutions with LaTeX. I'm going to put these up on Teacher Pay Teachers in case you're interested. I'll leave a link in the description below. If you want to follow me, my social links are in the description below. And I thank you for watching. If you really did like this video, please like, subscribe, and hit the bell for notifications. It really does help the channel grow. And I thank you for watching, and I hope to see you in the next one. Have a great day.